Algebra 1, Lesson 3, Fractions. In this lesson, we will take a deep dive into the world of fractions. In a previous lesson, we defined fractions as being represented as a ratio of two integers. While that is true, in order to fully understand fractions, we have to define them in a more sophisticated manner. A basic definition of a fraction is that it is a type of number that represents a portion of a whole. One simple cliché example that you have probably seen before is that if you have a pie and cut it up into 6 equal pieces and take one piece out of it for yourself, you have taken 1/6 of the whole pie, with the remaining 5/6 left. Simple enough to understand, right? Fractions are usually expressed in the form of a over b, where a is the numerator and b is the denominator. The numerator represents the number of parts, and the denominator represents the total number of parts. There are 3 types of fractions: proper fractions, improper fractions, and mixed fractions. 1. Proper fractions. A proper fraction is a fraction where the numerator is smaller than the denominator. For example, 2/7, 1/3, and 7/10 are proper fractions. 2. Improper fractions. An improper fraction is a fraction where the numerator is larger than or equal to the denominator. For example, 9/4, 5/3, and 13/6 are improper fractions. 3. Mixed fractions. A mixed fraction is a combination of a whole number and a proper fraction. For example, 3 1/4, 2 2/5, and 3 1/9 are mixed fractions. Now let's get into how we evaluate and solve fraction problems using the basic operations we used with integers in the previous lesson. Adding and subtracting fractions can be done by manipulating one or both of the fractions to have the same denominator. If the denominators are already the same, we simply add or subtract the numerators together and keep the same denominator to get our final solution. Be careful when subtracting fractions, because you may get a negative fraction as the final answer and lose points on a test for forgetting the sign. Here we have a simple example where the denominators are the same. Evaluate 2/9 plus 3/9. We take the following steps to evaluate this expression. 1. We identify that the denominators are the same. 2. We add the two numerators together and place that value as the numerator for our final answer. Remember, we don't have to make any changes to the similar denominators, so our final answer is simply 5/9. Here we have a simple example where the denominators are not the same. Evaluate 6/7 plus 1/2. We take the following steps to evaluate this expression. 1. We identify that the denominators are not the same. 2. We manipulate both of the fractions with multiplication so that the denominators become the same number. We do this by multiplying each fraction by the other fraction's denominator divided by itself. Then we multiply across numerators and denominators. This would be equivalent to multiplying each fraction by 1, which does not change its real value. 3. Now that we have the new manipulated fractions, we add the numerators and keep the new denominator as part of the answer. The math looks like this. 2/2 times 6/7 equals 12/14. 1/2 times 7/7 equals 7/14. Finally, 12/14 plus 7/14 equals 19/14. So our final answer is 19/14. Now, with multiplying and dividing fractions, the rules are simpler. Like in the previous example, when you want to multiply fractions together, you simply multiply across the numerators and denominators to create a new fraction with both a new numerator and a new denominator, unless multiplying by 1 or 0. Here's a quick example. 2/3 times 1/5 equals 2 times 1 over 3 times 5, which equals 2/15. With dividing fractions, you need to switch the numerator and denominator of the second fraction and multiply as usual. Here's a quick example. 5/8 divided by 2/3 equals 5/8 times 3/2, which equals 15/16. Easy, right? It is also important to know how to convert between proper fractions, improper fractions, and mixed fractions. The steps are as follows. To convert an improper fraction to a mixed number, you need to divide the numerator by the denominator and write the quotient as the whole number part. The remainder becomes the numerator of the proper fraction, and the denominator remains the same. For example, to convert 9/2 to a mixed number, you divide 9 by 2 to get 4 with a remainder of 1. So the mixed number equivalent of 9/2 is 4 1/2. Similarly, to convert 4 1/2 to an improper fraction, you multiply the whole number by the denominator of the fraction part and add that value to the numerator while keeping the denominator intact. So 4 times 2 equals 8 and 8 plus 1 equals 9, which brings us back to the improper fraction 9/2. Simplifying fractions is a very important tool to learn to make our work with them much simple, obviously. To simplify a fraction, you need to divide both the numerator and denominator by their greatest common factor, or GCF. For example, to simplify 8/16, you need to find the GCF of 8 and 16, which is 8. Then, you can divide both 8 and 16 by 8 to get 1/2. Similarly, to simplify 25/30, you need to find the GCF of 25 and 30, which is 5. Then you can divide both 25 and 30 by 5 to get 5/6. In conclusion, fractions are an important part of mathematics, as they help us solve real-world problems that otherwise couldn't have been solved with only whole numbers. They can be added, subtracted, multiplied, and divided using specific rules, as well as converted and simplified to help make evaluating the expressions easier. Keep practicing, and we'll see you in the next lesson.